5 prime, and this is 3 prime. And take away. Okay, this is P site on the top. Okay, what is going to be the A site looks like? A site. I'm using this one. We have another one. Let's say another A coming. Okay, either H, OH, goes here we have O, CH2. Now here we're going to draw it easy. Okay, phosphate with a tRNA. Otherwise it's too long. Okay, it goes here. We have C, then I'm going to draw in right here. NRH, NH2, RN2, and this will be, this will be C, O, goes here will be C, and this is NH2, it will be RN plus 2, and this is H. I'm using Rn plus 1, Rn, and Rn plus 2 indicates there is a different side chain of amino acids. What's going to happen? How they connected? This amine group right here will react with this carboxy group right there. So very simple, this is actually inserted. And this is going to be moved here. Okay, so what's going to happen? They do a little bit of twisted. What they do twisted? Since they reacted, this goes here will be Rn2. Then go H, NH, go to O, C, go to C, O, goes here, C, O, N1, H, NH, and goes here, carbon oxy base, C, H, NH, and this is RN. So they are going this way. Okay? Now, I forgot to mention, when they synthesize, they always from is N to C of the amino acids. Now, by the way, the amino acid, when they collected, they become a peptides. When they become a peptide, that is a primary structure of the DNA. And then you go further, alpha, beta helix, you become secondary structure. So you have a motif the domain that become a tertiary structure, and later on you combine everything, that's a quaternary structure. So this is going to be like this. And then for the P site, these all got, remember they translocated. Go back to like that. Okay? So they move this way. Now, when you see these, you're going to be a little bit confused, I'm telling you. Why? This tRNA is on the top, and this tRNA here is at the bottom. So how you understand this? From this picture to here, the structure, you need to make sure it is upside down. This is the key. On your notebook, when you wrote here and you wrote here, this is going to be turned around. Then you understand it. Because here, the tRNA is at the bottom, and here the tRNA is on the top. But exactly the same how they do the translocation and the peptidation, and the transpeptidation. Okay? So this is the elongation. Last one, termination. Okay, how are we going to do termination? Let's say we had a ribosome is already there. Okay, this will be carry on. This is almost done because we have EPA. There's no condition there. This is going to be a very long chain here. A very, very long amino acid chain there. How do we know it's going to stop there? Number one, they're going to have a releasing factor 1, 2, 3. Once you have a releasing factor 1, 2, 3, this amino acid base, amino acid synthesis 1 will be released. And at the same time, the 50S subunits and 30S subunits will be separated. And then initial factor 3 will be reattached to it. And this will make sure they stay separate. And when a new guy is coming, they're gonna repeat to do the same thing I draw right there. I already pick it out because it's too long. Okay, that's the whole process of we talk about the termination. Now, of course, the termination, we need signal is stop codon. What are they? UAA, UGA, and the UAG. Once you see these coming, that means you have to stop. Okay, so 2 signals. Stop codon and the releasing factor 1, 2, 3. Initial factor 3 will be reattached, make sure they're separated. And then they do a next cycle. And this, we have to repeat it again. If they ever stopped, the bacterial translation will be stopped, which means sometimes their essential amino acids will not be synthesized. They are not going to be enough energy, resource, and the nutrition resource to survive. So it is very important. Okay, so start from here, we finished talk about the translation. And we finished talk about all those 3. So thank you very much. And my next couple of videos, we will talk about metabolism, focus on the aerobic respiration, some fermentation, and we also gonna do maybe a general chemistry introduction. Okay, thank you. I'll see you next time. Bye.